Hey, Plumber-Tom here. If you're preparing for a plumbing state test or trying to improve your knowledge of code and understanding of plumbing, don't forget to check in the description below for links to study guides, online courses, and other resources that will help you to learn the code and pass your test. When you click on those links and purchase resources, you're helping me to be able to create more great content. Thanks for watching. NFPA 13D, standard for the installation of sprinkler systems in 1 and 2 family dwellings and manufactured homes. Hello, welcome to this presentation of the NFPA 13D. My name is Thomas, and in this presentation we are going to look at a very important chapter. It is Chapter 8. The title is Sprinkler Position and Location. Think about this. If the entire purpose of a fire sprinkler system is to put out a fire, then the position and location of those sprinkler heads has everything to do with the success of the system. You have to know where these should be, and this chapter spells it out. We're going to look at illustrations, we're going to look at tables, we're going to get a really good idea of how this works and where you should be planning to place a sprinkler head. If there's a state test and they're going to have questions from the NFPA 13D, I assume there may be some of those questions from this chapter, so pay close attention, get your book out, follow along. Let's get into Chapter 8. Join me in 8.1.1. We're going to start off looking at sloped ceilings. First paragraph there explains that for slope ceilings, they're going to give a maximum distance, that's S. This is a dimension that follows the slope line of the ceiling, the whole surface. That measurement is along the ceiling from one sprinkler head to another or to a wall. 8.1.1.2 says that the listed spacing between heads shall be not less than 8 feet from one sprinkler to another. So that's the minimum distance you can go, or as close as they can come together in general, is 8 feet. 8.1.1.3 and 8.1.1.4 come from later editions of this code, and you may or may not have this in your book, but I think it's worth looking at. 8.1.1.3 states that the sprinkler head shall be installed within 36 inches vertically from the peak. So they want to make sure that one of them's up pretty high within that space. There are a few diagrams, and this is taken from the 2025 version. You'll see less diagrams in earlier versions of this code, but let's have a look at these. You see several sprinkler heads, the minimum spacing of 8 feet, and one of those within 36 inches of the peak of the roof, as was described previously. Different scenario here. We have a sloped roof, and then it flattens out. So a head up at the top, measuring down, there's 8 feet in between those, at least not less than 8 feet, and we have a sprinkler head on the sloped roof on the left side. Here we see an illustration of the fact that this sloped roof has a head within 36 inches of the top peak of that slope. And this head, even though it comes down on the slope side, we have a flat roof and a wall to the right, it is still within 36 inches of that top peak of the ceiling. In this illustration, the sprinkler head is installed in the top flat part, which would be the peak, and it is within 1/2 S dimension, or in other words, if I take a measurement along the ceiling from the head down to the wall and cut that in half, that's where it should be for the placement of the sprinkler here. Now again, section 8.1.1.4 comes from the later editions. I'm looking at a 2025 edition of the NFPA 13D, but might be worth noting here. For ceilings with a slope exceeding 2 inches in 12, we're talking about the overall pitch of the roof, there are some requirements for this. The position of the head is to shoot downward along the slope. It also gives some information about deflectors that are parallel to the wall, stating that those deflectors should shoot water along the slope. Have a closer look at this. We have the slope of the roof. The sprinkler is on the upper left side, and note that the sprinkler deflector, it's a little L shape on that triangle, That's indicating that it is shooting along the slope. The idea here is if we shoot water directly into the slope of the roof, it's just going to hit that ceiling and fall straight down. What we need is a disbursement of water, so that angle has to follow the slope so that that water is spreading down along the ceiling. That's the intent of this. We see a similar concept here on diagram B, where we have two heads. These are sidewall mounted and they're parallel to that ceiling. And those deflectors are arranged so that those sprays will go parallel to the ceiling and spread the water across so that we can hit everything as that water is falling down. 8.1.2 refers to non-residential sprinklers, and regarding the placement of those, and that's a different type of sprinkler head. We talked about those in other presentations. But when we're installing those, it says you need to go to the NFPA 13. Now the difference there is NFPA 13D is specific to residential installations. The NFPA 13 is all about general, like all sprinkler installations. And those non-residential sprinklers would fit into that. So that's how you would figure out, like, well, if I'm going to use a non-residential head, just look into the NFPA 13. 8.1.3 states that if there's a physical barrier that prevents a sprinkler from directly spraying, then there shall be no distance limit between sprinklers, meaning like you can bring them close together if we're having problems with getting adequate spray because there's something in the way. 8.1.4 talks about the operating pressure, and it says that we have to be able to maintain a pressure that's higher than the minimum operating pressure for the sprinkler. So you might look into the sprinkler specs and find out, well, what is it going to take to make this thing run? We have to at least meet that. Or it says there has to have a minimum of 7 psi, and that's operating. That means like the system is open, water's moving, and we're getting 7 psi coming through the head. That's a flow pressure. Let's move on to 8.2, where we're going to find a lot of information about the position of the sprinklers. 8.2.1.1 starts us off with pendant or upright sprinklers. It says the deflector has to be between 1 to 4 inches from the ceiling. We need to keep it up close to the top of the ceiling. You think that's where all the heat's going to be, right? The hottest air is going to move to the very top. We want that thing to pop open when that level reaches that high temperature as quickly as possible. 8.2.1.2, we have A here, an illustration of what to do if a sprinkler is near a beam. There's several options. It can be positioned within the beam and protrude down below the beam. We see that on the left. It could be recessed into the beam with a recessed sprinkler head, or a sprinkler can also be set next to a beam, and this becomes somewhat of an obstruction if that sprinkler is within 1 to 4 inches of the ceiling. So we're allowed to bring that down below the beam within 2 inches of the beam and between 1 to 2 inches below the beam. Let's talk about a different sprinkler type here. We have a sidewall sprinkler in 8.2.2. Residential sidewall sprinklers, they're coming out from the wall and deflecting water across the room. These are supposed to be positioned so the deflectors are within 4 to 6 inches from the ceiling. So those need to be installed up high. And the deflectors are to be no more than 6 inches from any sidewall. Once again, we see a statement of the non-residential. You can get a non-residential sidewall sprinkler, and those would be positioned according to the NFPA 13, as we talked about before. 8.2.4, when there are basements without ceilings, say we have an unfinished basement, where do you put the sprinkler heads? Well, in those cases, it says that you would look at the plan for the future. So what's this going to look like when it's finished, and anticipate those room walls and put those sprinkler heads in places that would be appropriate for those future walls. 8.2.5 talks about obstructions to the residential sprinklers. And we get into quite a bit more detail here as to how to handle the placement of heads in relation to an obstruction. Now, there's a lot of things that could obstruct the flow of a sprinkler, whether it's a pennant coming down from the ceiling or a sidewall sprinkler. If there's little protrusions, box outs, even ceiling fans, there's a lot of these things that can deflect water, and we're going to look at how do you handle those. This section has quite a few illustrations, so we'll get into some detail here. First of all, let's look at 8.2.5.1.1. Pendants have to be at least 36 inches away from any obstructions. So this is a normal pendant. It says the distance is to be measured from the center of the sprinkler to the center of the obstruction. Now keep that in mind, right? Center of sprinkler to center of obstruction. 8.2.5.1.3 says if sprinklers cannot be located 36 inches away, then an additional sprinkler shall be located on the other side of the obstacle. So you can add another sprinkler if it's like spatially this isn't going to work to keep it 36 inches away from the obstruction. You can put another one on the other side. Let's look at a specific here. What if you have a ceiling fan? Those blades could serve as an obstruction, and so we get this requirement. If the blade encompasses more than 50% of the area in plan view, that means you're looking down into the room, and those blade surfaces, if they're taking up more than half of the space of the room, then sprinklers are installed according to 8.5.2.3, and that section's all about dealing with a solid obstruction. So if the fan is taking up half the space, we're just going to say this thing is an obstruction. It's considered a full obstruction, and we'll distance our sprinkler heads according to that. Now 8.2.5.1.5 is a newer section. In the 2025, we're seeing an obstruction in a hallway. And if you've got this hallway and say there's a column coming up through the middle, this section says that you have to be 12 inches away from that. And if you can keep that distance to the obstruction, then they're going to consider that okay, so long as the hallway is 6 feet or less in width. What this will do is as that sprinkler goes, there's that shadow area created by the obstruction, but it's not enough to limit the sprinkler's ability to put out the fire. So this arrangement of things is going to be considered okay. Let's look at 8.2.5.2. Now we're looking at sidewall sprinklers, and these are to be located at least 5 feet away from an obstruction. And this is measured from the center of the sprinkler, once again, to the center of the obstruction. If 5 feet from the obstruction is not possible, then an additional sprinkler could be installed on either side of the obstruction. We just want to make sure we've got full coverage without major shadow areas. In the 2025 edition of the code, we see this 8.2.5.2.5 diagram. Once again, it's just like the other one. You've got a 6 foot wide hallway. This time we're dealing with a sidewall sprinkler, but as long as it's 12 inches away from the obstruction, the shadow area on the other side, they're calling that the allowable obstruction zone. Basically, that water is going to have enough proximity within that 6 feet to be able to splash around the obstruction and we can get the job done. Let's move on to 8.2.5.3, and we're going to look at continuous obstructions to pendant sprinklers. This means like this is a solid block out, something that's going to stop water from flowing and create a shadow area. And we're going to look at tables and figures that help us understand where to place our heads in relation to those to make sure that we get the water down where it needs to be, put out that fire. Start with the table 8.2.5.3.2. This is position of sprinklers to avoid obstructions. And this is for residential upright pendants. Upright and pendant. Upright meaning that it comes off the top of the pipe. Pendant meaning it's coming down from the ceiling, right? Either way, here we have this table, and it's used in conjunction with a figure that we'll look at here. But start off far left column, this is all feet. This is distance from the sprinkler to the side of the obstruction. And then we have millimeters. We're going to ignore the millimeters because we're American. And we're going to go to inches, which this is allowable distance of the deflector above the bottom of the obstruction. Have a look here at the figure that goes along with this table. The big black rectangle is the obstruction. The triangle over on the left is the sprinkler. Then you've got A is the distance from the sprinkler in feet, and B is the elevation above the bottom of the obstruction in inches. So if we go back to the table, let's take one for example. What if it's 4 feet from the obstruction? We use this line 4 feet and we come over. That means that the head can be 5 inches above the bottom of the obstruction. Let's put that onto our figure. A equals 4 feet and B is 5 inches. And if it's 5 inches up, it's going to give me enough of an angle to still get around that obstruction, but it doesn't have to be all the way down even with the obstruction. Now, this is where, like, in relation to that obstruction, if I get too high, I create too much of a shadow area. If it's too low, well, we don't want it too low down in the room. So we can kind of figure out exactly where that needs to be to make sure that that water disperses and gets to that shadow area, but also it doesn't have to be too low.
Please remember that a pendant sprinkler must be between 1 to 4 inches from the ceiling, and a sidewall sprinkler must be between 4 to 6 inches from the ceiling. And why is that? If the sprinkler is too low from the ceiling, then the heat will collect above it, and the room could go into flashover before the sprinkler opens up and releases the water. For this reason, the sprinklers need to be towards the top of the room.
That's the general principle behind all of these figures that we're going to look at as we continue here. Here's another figure. Now this one's more of a standalone. It does not have a table that goes with it, but it does have a formula. This figure, which is 8.2.5.3.3, figure A, is for the position of a sprinkler to avoid obstruction against a wall. So here's our scenario 1, residential upright and pendant. We've got a pendant coming down from the ceiling here. A is the distance away from the obstruction, and B is how high that pendant can be above the obstruction. But there's a formula that we work out here. A has to be greater than or equal to D, that's the distance, that width of the obstruction, minus a standard 8 inches, plus the height of B. And when we put all that together, we can get our distance for A. That's the minimum, right? It could be a little farther out, but that's the closest we could get to the obstruction with a certain elevation B. Now, once again, there's not a table for this, but I can kind of throw in some numbers here and see where it ends up.
Let's take a minute to try this out. Let's figure out A if D equals 25 and B equals 6 inches. Again, remember, our goal is to get this sprinkler head as close to the ceiling as we can, because we want to be able to knock out that fire in a potential flashover situation. But given these two numbers, let's see. Plug them in. A equals D, which is 25, minus 8 inches, plus 6 inches. That's going to give us A equals 25 minus 8 is 17, plus 6 inches. And 17 plus 6 equals 23 inches. There we have it. A would be 23 inches away from the obstruction. That's going to give us the right angle to be able to get around the obstruction, hit the shadow area, put the fire out.
And that's how about half of these figures will work. So you'll want to get to know this formula right here. A is greater than or equal to D, that's the obstruction distance, minus 8 inches, plus B, which is the height above the obstruction. Now you can ignore the second line that's dealing with millimeters. And once again, this is as long as D is smaller than or less than or equal to 30 inches. All right, how you doing? You hanging in there? We're about halfway through the information that I have for you from Chapter 8. So we're going to take a break here. Join me in the next presentation where we will finish discussing sprinkler position and location. I'll see you there.